Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my course,
Good afternoon, dear faculty members. I hope you all doing well. So we'll start for the day. Gaurav sir, good afternoon.
Good afternoon, Shweta ma'am.
Yes, sir, you can take over the class. You can start.
Okay, thank you so much. Welcome to all. I hope you have gone through the basics of blockchain, whatever we have covered till yesterday. And if you have any doubts, any queries related to the previous topics, please let me know, and we can start over it, and we can start taking questions from you from the previous classes. So I'll take some questions from the previous topics. If anyone having some doubts, let's take questions for 1 minute, and then we can move forward. If anyone having any kind of doubt, any questions, any queries, please feel free to uh, drop your questions in the comment in the chat box. Hope my screen is visible to all of.
Yeah, yes, sir, it is visible.
So let's start. So in today's session, we will cover some clauses and the terminologies, the keywords, the components we have gone through in 2 days. So we will cover up those keywords and those topics in one go. And let's understand the all the things that whatever which we left before, right? So let's move forward. So where we have the topics related to that. So blockchain, so which is a decentralized digital ledger storing transaction immutability, right? So blockchain, block, what is a block? A container of transaction data added to the blockchain. Basically, it is a kind of a file storage thing that basically eventually becomes a block of of a blockchain, and becomes a immutable part of any network. The node is nothing but a computer that maintains and validates the blockchain, right? It is a kind of one of the component that allows the blockchain block data to be added onto a network. Decentralized is a concept. It's a kind of a distribution of control across multiple participants. So that's how decentralization works. Basically, no one has the authority to control that particular ecosystem. DLT, that is decentralized technology, distributed ledger technology. So synchronized digital database. So multiple data storages are stored, and they are in sync with each other, so that the communication will be very smooth and easy to maintain and handle, right? So let's move to the next one. The hash, we know, it is a cryptographic identifier for the blocks and the data. Basically, it is a kind of a function or the process through which we pass up our inputs and we'll get some encrypted data values, right? Uh, Related to for that particular input. Consensus mechanism we have. Basically, it is basically a kind of a protocol for transaction validation, uh, where the how blocks are validated, transactions are validated, and then uh, it is added to the blockchain network, right? So the consensus mechanism, we have different types of consensus mechanism. In the upcoming slides, I'll tell you how the consensus mechanism works. So earlier we have covered proof of work in the previous lecture. So proof of work is a mining based validation that requires a computational power. Basically, you have to find some mathematical puzzles in order to find in order to get the validation from the other peer members, right? The other the component is proof of stake. It is also a kind of a consensus mechanism where the validation based on the token holdings and staking. So in today's lecture, we will cover this proof of stake concept in detail. uh, Next component is related to smart contract. So it is basically a piece of code, a coding file that we and write on a blockchain network. So smart contracts is a concept of a Ethereum blockchain network. So it is a kind of a self-executing contract, or you can say the file, coded file with terms is terms and conditions are incorporated as per the business needs or the requirements. And whatever the codes are written over there, and the condition, whenever the conditions are met, it executes its functions, right? How it works. Now we have also gone through the wallet. What is a wallet? We have covered so far the types of wallets and how wallet works. So basically, it is a tool to store, manage, and manage cryptocurrencies or your digital assets, your public key, private keys, right? So public key, private keys, we have already covered. Now gas fee. Gas fee is also a concept of a Ethereum. So it is a transaction fee in blockchain network. So basically, gas fee is what you pay for the transaction. So as you know, in current banking system or centralized networking system, if you use any platform or any services, you have to pay some uh, payments, you have to pay some fees to that service provider, right? So in blockchains network, we also pay some we also pay some service fee. In Ethereum, that service fee is known as a gas fee. So transaction fee in blockchain network, basically it is in general termed as, and gas fee in general is called as for the any kind of blockchain. So the token, it is a digital representation of asset or utilities that are built upon a specific blockchain network using their protocols and the business ideas, right? So token can be of different type. There are multiple type of tokens we have in blockchain ecosystem. So cryptocurrencies, altcoins, stable coins, and so on. So we will cover the token types of tokens in upcoming lectures also. So tokens are a digital representation of an asset or utilities which are also relies which is something related to your real world things. So token can be classified on the basis of whatever the requirement it is, right? Now let's go to next slide. So altcoin, as I have told you, so altcoin, stable coins, these are a type of a tokens or the currencies or coins. In it is used as in the blockchain ecosystem. So altcoin is any cryptocurrency that other than the Bitcoin. Why we call it as a altcoin? Because Bitcoin was the first cryptocurrency or the digital coin which came into existence after the launch of the Bitcoin network in 2009 by Satoshi Nakamoto, the person who created the Bitcoin. So that's why the bit after that, whatever network or whatever cryptocurrency or the coin comes into a market or into existence, that is known as a altcoin. It is an acronym of alternative coin. A stable coin, similar to digital currency, cryptocurrency pegged to a stable asset like USD. So somehow it is related to your fiat currency's value, right? So as we know, in financial system, whatever number of denominations a country print in digital on paper note or the coins, it is related to the value of the gold it is having there in storage, right, in the in the central banks. So it is similar to in the digital world and the current financial system. So cryptocurrencies, which is equivalent to the value of the current fiat currencies, is known as the stable coins. So now next concept is related to DeFi. It's an acronym for D. DC D is related to decentralized, and FI is for finance. So decentralized finance application, it is known as and without intermediaries, where the financial uh, applications was not dependent centralized exchanges. Peer-to-peer exchange is processed, and no central authority is having access over it. Hello, am I audible? Hello, hello, Sushmita ma'am.
Yeah, yes, sir.
Somehow I lost my screen sharing, and the recording was started some in between somewhere.
No, the recording is going on. You're not able to share your screen.
No, I was sharing, but in between I got some notification related to the recording was stopped or something related to that. Okay, I'm sharing my screen again.
Yeah, yeah.
Is my screen visible?
Yes, sir, it is visible.
So we were discussing the decentralized exchange, which is a peer-to-peer crypto exchange where we exchange where we can buy, sell, or trade our cryptocurrencies or the tokens, right? So it is handled by a decentralized entities, right? So as compared to in current scenario in current world, where BSE and NSEs are related to the shareholding and share controlling authority in India. It is similar to that, but is in a decentralized manner. Now, where our next concept is DAO. So DAO is also an acronym of decentralized autonomous organization. Basically, it is a organization. It is a concept where the organization and governance takes place on the basis of the decentralization, and the principles of decentralization and distribution takes place here. And because of this thing, nobody has the authority to takes the decision to execute any operations and execute any kind of their activities into a particular system, right? So where the participants votes and votes for to execute and validate that particular thing to be executed into that particular system network. So DAO is a concept where decentralized in decentralized manners, members basically participate and raise their concerns over the networks and the governance. So DAO is a concept we will, and decentralized exchange are the two major things that we will also cover in upcoming lectures. So here I have just give you a gist about the concept, how DAO works, what is a DAO and what is a DEX. Let's go to next slide. So NFT also a part of also part of a blockchain network where it is known as a non-fungible tokens, right? It is a unique digital asset representing ownership. So whatever in real world, suppose you are having some asset, right? Any kind of asset, whether it is a land, property, any kind of bonds, shares, and images, whatever property you can assume. So in the digital world, in blockchain ecosystem, you can represent your real world asset in terms of digitization and in the terms of tokens. So if you are converting your real world asset into digital form, that takes place over the NFTs only. So NFTs basically it's non-fungible. You cannot funge tokens basically. There is a concept of fungible tokens and non-fungible tokens. In detail we will cover also. Fork is the other concept where protocol change, it has a two types, soft fork and hard fork. So forking is nothing but a concept of doing or changing your path from the original state of the blockchain. So forking is where suppose there is a concept of a fork when alternatively the longest chain concept comes into picture, and somebody wants to create some their own chains and don't want to be incorporated into a main chain. It somehow it is connected to a main chain, but it related to their own things, where developers in members or other users takes participation on particular chains. So whenever forking takes place on ecosystem or on a particular chain, that the second chain becomes the type of another chain, and also sometimes also known as a side chain or a parachain in that in some way. So forking is also another concept, which is a very detailed concept, and how forking takes place is a deep already a deep concept. Second one is now the another concept is immutability, right? So immutability we have already covered. So it is a concept of inability to alter data once recorded on the blockchain. So it is one of the main concept of blockchain and decentralization. Now the 50% attack here is so network control by majority and mining stakes. So in previous lecture I have told you, if someone has the validation, and any transaction or any block gets the validation of the 51% or the majority of the network participants, right? That transaction becomes and added into a particular block. So same as in the blockchain, whenever attack has to be happen. So to attack or to hack anything in blockchain, the mine the this hackers or the members who wanted to hack or the attack or wanted to attack the network, they have to achieve the 51% of the majority of the networks or the nodes in to basically mine or stake the chain to change the data over the network. So next is tokenization. So basically NFT is a part kind of a token, right? Now the tokenization is a process where you are representing your real world something or data asset, anything asset as a blockchain token. So that is a process, and NFT is a kind of a it's a somehow becomes a part of tokenization, or any coin. It is a kind of a tokenization. Basically you are altcoin, you can take as an example of the tokenization. So tokenization is a kind of an umbrella term where under which NFT, altcoin, and stable coins takes place. There is also a utility token. So some platforms also use the concept of utility, where it is related. It is somehow similar to crypto tokens, but it is different in operations in technical terms. Now comes to validator. So validator basically it's a kind of a node. Node is kind of a participant or a member who has the ability to validate the validate the transactions, or the confirms the transaction in POS network. So validator nodes are the concept of the Ethereum network only, right? So POS, in POS concepts, network validators exist in the network. Now the interoperability. So whenever we talk about the interoperability, what does it mean? So if someone uh, wants to buy some tokens on Bitcoin and wants to purchase some real world asset or some other things using the Ethereum. So there has to be a between a cross chain communication, right? um, so that concept is known as the interoperability. uh, it is a concept where you exchange, or you basically convert your one type of token or your one type of currency, and it basically you are taking away from the existence, from the generation of the network to the destination network. So the interoperability is a concept of communication between two different types of blockchain network. So cross chain communication and the value exchange is known as the interoperability, right? So layer 1 and layer 2 is the concept of the blockchain network. So there are multiple level of blockchain, multiple layers of the blockchain. So layer 1, layer 2, layer 0, layer 3. So kind of, so basically base blockchain and scalability layers. So whatever blockchain you have heard about in the market, right? Related to Ethereum, Bitcoin. So these are the layer 1 solutions, right? And on the top of that, to increase the transactions speed, all right, basically the throughput is a concept where when the number of block per second or within a particular time will increase, right? So so where layer 2 solutions comes when we wanted to scale up our network. So in layer 2, you can take an example of Polygon. Like Polygon is one of the best example of layer 2 solution, where uh, transactions speeds are much higher than the Ethereum, and uh, the transaction fees, basically a platform fee, is also lesser than the Ethereum one, right? So these are the concept of layer 1 and layer 2. Now the cryptography, you all know about very well. The cryptography is a secure communication and transactions mechanism where we apply the algorithms to manage the security between the two peers, or between two person, using any kind of medium, right? So cryptography is one of the concept in digital communication. So fiat currency, as I have told you, so government issued traditional currency in terms of just like INR, USD, right? So these are the fiat currencies which is used by the users in their country. Now let's come to a types of blockchain network. So we have different type of blockchain network in Web3 and the blockchain ecosystem. So can anyone tell me how many types of blockchain network we have? Uh, let's take a let's please put your answers in chat box. Let's take input from the students. Whatever you have heard about the concept of the public kind of a network, types of network you have heard, so please comment, or please share your feedback in. Okay, three types. Can you mention those three types, Miss? Okay, yes, it is correct. Yes. So let's take a look into types of blockchain network. So we have a public blockchains, right? So public blockchains, which are open network where anyone can participate and validate transactions. So it doesn't allow, it allows everyone to participate, and nobody is barred from to take participation or to use this network, right? So what are the main characteristics? So decentralized, it's a one of the major concept characteristic is decentralized. So any public blockchain, so it's any public blockchain is a decentralized in nature, because everyone has having its authority to basically participate and to govern this ecosystem or the chain. Open and transparent, because of because it's a public in nature, so it is open and everyone see the data of any kind of transaction details, the amount we have shared to anyone, but the identity of that particular person will be not accessible. So you can just say that the privacy, i- it is kind of open, transparent, but somehow it is also maintaining your privacy, because blockchain doesn't store your values, your real world identity values, right? Your name, passwords, or your ID number, anything like driving license, Aadhaar number, any kind of these details are never stored by the public blockchains. So the Bitcoin and Ethereum are one of the best example of the public blockchain, because Bitcoin was the pioneer, and Ethereum is one of the major market right now, which is built by the taking inspiration from the Bitcoin, right? So whatever the difficulties they have faced in Bitcoin network, or in technical terms, so they have come up with a solution and launch Ethereum. So Ethereum is a network kind of built by one of the developer, like his creator is Vitalik Buterin. You can Google or over on the internet, and you can get the idea of how Ethereum came into an existence, right? So what are the advantages of the public blockchain? So first is highly secure, transparent, and resistant to censorship. So because it is a public, so no government authority the right has ownership to basically govern it, and to basically monitor it. So resistance to censorship is always available in public blockchain. So that's why you also know in India, Bitcoin and Ethereum are not legalized in that term, right? So that's the one of the major thing which has to be addressed by some countries. They are working upon. India is also working on some their concept of legalizing of the cryptocurrencies and all, which could be monitored, and which could be um, uh, able to handle these situations when something goes wrong. Now, what is the disadvantages? So in public network, it is highly energy consumption because the in Bitcoin, as you know, the proof of work is one of the consensus mechanism works, where miners have to do computational work, and using those computational work, they use high configuration of the computer system storage GPUs, which basically uses the high energy of the electricities, right? Lower the transaction speed as compared to the other one, the public, because as large as the public blockchain are, so it takes the time to convert to basically add a block into a network. So in terms of blockchain, in terms of Bitcoin network, every block is added to the network in every 10 minutes, whereas the in Ethereum it is less than that. So because it has come up with some solution where proof of work is not applicable and proof of stake is applicable in Ethereum. So that's they have come up. So we will cover up those things also. Lower transaction fees, and then the lack of privacy. So where you and in public networks you can also face the lack of privacy. How? Basically, in terms of privacy, as you know, blockchain never stores your public data like name, gender, or any addresses or kind of details. But in terms of the privacy, in terms of your public address, everyone knows. So in on public networks, anyone can get the public address of anyone else, and whatever the amount they have sent to one person to other person to then third person, any transaction. So the traceability of the transaction of the particular users can be accessible by anyone in the network. So this is one of the main disadvantages, these three. Now let's come to the another one, the blockchain network. So next is private blockchain. So private blockchain is a closed network within the control, access, and permission, where only the certain number of members are allowed to take participation and to use the facility of that particular network. uh, it's a basically closed loop. It's a kind of an entity. Let's take an example of a network. So suppose if you are an employee of a government, of any state government, so a state government has its own blockchain network over which they are communicating with every members within that particular organization, and nobody is allowed to access that particular message details in that network, right? So that's how private blockchain works. So only the allowed members and the participant members are able to do the communication in between with the peer members. So highly higher privacy is there. So privacy never compromised in the private blockchains, everything, every detail. So you can basically uh, make the standards of the privacy accessibility, and basically maintain the infrastructure on the basis of the requirement of how to manage and who has the authority to access the data, and how much authority they have to how much access the data. So right, so basically the details. So higher privacy, centralized control is there. So basically it lose the concept of one of the concept of the blockchain, which is the centralization. But somehow it is applicable, it is applying on the other component like like security, and kind of the immutability, peer-to-peer connections, peer-to-peer communication. So these other components is applicable in this private blockchain. So central control is there. Anyone, the central authority has, it could be a one member or a group of member who's controlling and monitoring the everything, every situation, every event, every transaction. Right. So example is Hyperledger Fabric, which is also a kind of open source platform built upon built you built by the Linux Foundation, right? R3 Coda is one of the other example which provides the framework to build your private blockchain network. What are the advantages to to use private blockchains. So it enhances the privacy, as we have discussed. Efficient and faster transaction. So as the only limited number of users are participant in the network, so the communication is reliable and fixed, and as the communication path minimizes, so the speed of the message transactions and the communication between the peers are also fast, right? And controlled participation. So it is control basically. What does it means? So centralized control over the private blockchain. So only authorized people are able to take the participation and to do transaction, to do communication between the peers and the other members. So these are the advantages. What are the disadvantage? As the lack of decentralization, as I have told you. So decentralization is not there because the central authority, it is a private blockchain. So decentralized is not applicable here. Potential for centralized corruption. So as you know, the central entity can be corrupted, and the chances of to basically get affected the data and the information available, right, within that particular network. Now, due to this control participations and the centralized control, the privacy, transparency is also limited. So only authorized person have the limited kind of transparency. So if you are on the top hierarchy, on the top level of hierarchy, you are having much chances to get the all the details. If you are on the very lower stage of the hierarchy, so you might have the very basic detail of the network of that particular chain, right? Now let's come to the another one, that is the consortium blockchain. So consortium blockchain where the consensus protocol process is controlled by a group of organizations. So suppose if certain amount of companies of any domain of any, suppose let's take an example of automotive vehicles, right? uh, where Mahindra, Tata, Maruti Suzuki, Hyundai, and Honda, kind of these are companies who is manufacturing the automobiles, decided and come and form a group where the communication between and the standardization of the products will be takes place, and they form a blockchain network where the everything will be secured and manageable by only participant members, right? So here the network when comes into when this group forms, they basically form a network within that particular organization. So it is a network between the organization, between the group, right? So that's why it is called as a consortium blockchain, because it is handling the group of members, right, or organizations. So characteristics are related with the semi-decentralized, because every member is having the authority. So semi-decentralization concept is there. Access are restricted to consortium members only. It's just similar to private blockchain. Only selected members or the or the only participant members are able to do transaction and having the accessibility to access the data and the information. But in consortium blockchain, the collaborative decisions making are there. So whenever you wanted to change, whenever you wanted to propose anything, so consortium based blockchain, collaborative decision. So every decision should be in collaborative form. Everyone has to provide their inputs for initiation or the finalization of anything, any process or any decision, right? So that's how consortium works. Now the example are the quorum. Quorum is one of the kind of a consortium type blockchain. Energy Web Foundations is another example. So where they take place of the decisions and all. What are the advantages? So balance between transparency and the privacy, where transparency is also there, and but with the privacies. So only private data. Suppose if I wanted to share my name, so only my name will be visible to the other members, not my phone number, not my driving license number, my passport number, the other details. and related to that and similar to that kind of data. So only pre-decided kind of information only visible to the members, only the between the network members or the peer members. So that's how we are maintaining maintaining the privacy in the consortium blockchain, where while allowing the transparency approach over there. So efficient in collaboration, right? So it is very efficient because collaborative efforts are taken place here. Every decision has to be taken by the members only. Reduce the transaction cost because it is a collaborative effort, so the whatever the platform fee is there, it will be distributed among the members. So let's say suppose five members are five organization are the part of a network, and the transaction cost is coming up to 10 to doing a transaction, 10 rupees. So the 10 rupees will be divided equally to all the members, for example, right? So every for 2 rupees equivalent to for 2 rupees every member is liable to pay to do the transactions, right? So the it reduces the basically transaction costs. What are the advantage of this? So required trust among the participants. So as you know, the organization and the entity or the companies are very vulnerable to do these kinds of things. They are very prone to trust the other members, right? So it requires very hard trusteeship between the members. Less transparent than the public blockchain, but yeah, it is applying kind of a semi-transparency, right? Let's move to the other one. We have covered the public chain, private chain, consortium chain. Now we have another one. This is the hybrid chain. So what is the hybrid chain? As it's a combination of, it basically combines the features of public chain and the private chain, right? The combination of public and private features. So flexibility in data control, the cross communication, privacy. It handles the privacy, and also handles the transparency between decentralization, peer-to-peer communication. The all kinds of the things are taken place here, right? And customizable, right? You can govern also, customizable governance. So how many to whom you wanted to govern, you wanted to monitor. So these kinds of things you can also do in hybrid blockchains. So example are dragon chain, IBM food trust is one of the best example. Advantages are flexibility and scalability. So hybrid chain are more scalable than the public and private blockchains. Enhance the security and customizable privacies. Now I have just left this out, the section of disadvantages. Please, I wanted you all to answer this question, disadvantages. What are the disadvantages of hybrid blockchain? So please write it in the comment, sorry, in the chat box, so that I can get the you are understanding what we have gone through till now. So write the disadvantages of hybrid blockchain. So it is one of your tasks to do in today's lecture, right? Let's take 2 minutes, and please provide your inputs, and then we can move to another concept. We will in detail work on the proof of stake, right? Let's take 2 minutes and answer me what are the disadvantages of hybrid blockchain. Hello everyone. Please paste your answer in chat box so that I can go through it. What are the disadvantages of hybrid blockchain? No answers. Let's move forward then. So, how proof of stake works? So, POS is the proof of stake, right? Uh, so let me tell you first thing. So first detail about the proof of stake, right? So proof of stake consensus algorithm got introduced in 2011, right? Uh, why it is really why we came up with the solution of the proof of stake? Because of some problems associated with the proof of work. So that's why we came up the proof of stake concept. Because earlier in Ethereum blockchain also they were implementing proof of work, and but later on when they have upgraded their all entire blockchain, so they came up with the solution of the proof of stakes, where the large what are the what was the problem associated with, so that with proof of work, which was related to it requires the large computational capabilities to solve problems, right? Therefore it uses a large amount of electricity and power, whereas proof of stake links the mining power to the number of coins of a person possesses rather than the computational power. So we will go through in detail how this works, right? So the mining is limited to mining percentage of the transaction, right? So reflecting to their ownership stake. So proof of stake is a type of consensus mechanism where uh, algorithm that emphasize obtaining a distributed consensus. The block creator is chosen based on their stakes, and specific blockchain that use proof of stake, right? In this network, a person can mine or validate blocks depending on the number of stakes they hold in cryptocurrencies or the token of the native currencies of that particular blockchain network. The more that stakes, the more is the mining actually uh, of the power they have, right? So how it works, so basically let's go through the one by step process. So the user lock their tokens. So whenever suppose a transaction has been initiated by the user, and it the transaction comes into a mempool or a transaction pool, right? As soon as transaction comes into mempool, it basic all the miners gets the event and get notified that somebody has initiated a transaction, and they want every miner sorry every validator in proof of stake. Basically validation process is there, right? No mining process in proof of stake. So it's a kind of a process similar to mining, but in we say that validation. So any member who are the validators. So basically validator selection takes place. How validation takes place here is the network. Whoever the member of the network, they have different kind of roles. So somebody has the validation kind of role, somebody has the mining kind of role, somebody has the some other role, the basic user role, right? So one of the major role is validator node and validator role, basically you can say. So any so all the network all the members of the network who has having the validator node kind of role, the network randomly selects the validator based on the amount stake. So whenever so as I told, whenever transaction came into a mempool, every validator put some number of token whatever they have balance. Suppose I am having 100 tokens in my account balance, and I wanted to participate into transaction validation process. So here what I will do, I will put my 20 tokens into that validation process and lock into a particular place. Basically, I'm transferring some amount of token into that particular process validation, right? So I will put my 20 tokens as a kind of a stake that I wanted to be a participant in the validation process. So another member who is having 1000 tokens, he basically stake suppose 100, and another who has having 10,000, he staked only 10, similar to me. So base, it is a required, it is dependent on the validator, on the users, how much tokens they wanted to stake. And based on the staking value, the staked by a user, a random function in Ethereum blockchain runs. Basically, a process has been initiated, which is known as a rand DAO, right? So rand DAO is kind of a process where all the miners, all the validators choose randomly based on the staking their validation, staking their coins. So as it is also important to note it down that uh, the higher the value you stake, the possibilities to be get selected for validation process is higher, right? So suppose in five, suppose five members has taken participation in validation process, out of which suppose I get the chance to validate any kind of transaction, right? So validation, the chosen validator, I have been chosen by randomly by the network. The validator creates the and proposes a new block containing verified transaction. So what will I do? I basically picked up that transaction first, because I have been selected randomly by network using the random process or the random kind of algorithm. And I propose that whatever transaction I have picked up, it is valid and it is fulfill all the criteria to be incorporated into a block, right? And then what I will do, other validators, so I will broadcast the message. Now the process is similar to the proof of work, right? The rest of the process is similar to the proof of work, but the selection of the transaction is based on the random process, which is a randomly process. But in proof of work, what we have encountered, we have seen here there that only whoever is the first person getting the nonce value will be able to validate that transaction, and rest has to be validate the that nonce value itself, right? But in proof of stake, what we have done here is we have I have been chosen randomly by network, and now I have authority to validate any transaction. So suppose I have picked up any transaction or one transaction, and I have proposed that this transaction is valid. Now this transaction is valid. I have broadcast the message that I have picked up this particular address of transaction, and this is valid. Now other peer members in the network has to validate that particular transaction. And if I get the majority, right, if I get the agreement, consensus agreement, if majority of the persons have validated or approved my validation, then that transaction or that data will be added to the block, and it get added to the blockchain ultimately, right? And if I say that this transaction is invalid, but actually it was valid, but somehow maliciously I wanted to change that data, somehow I am corrupting to do this transaction, right? And somehow I have basically the transaction is valid, but I am proposing that it is invalid. And in return, suppose all the other members check that transaction is valid, and I'm proposing it invalid, which is wrong. So what they will do, they will get a consensus of 51% or the majority, right? And whatever stakes I have put it here to validate a transaction. So earlier I have told that I have put my 10 tokens to validate a transaction, right? So as soon as I do something wrong or something malicious, that number of tokens will be logged for permanent, right? For the entire life, and I will never get those tokens back. And I will also debar it, like for the process in future also, because I have initiated a transaction which was false, which was correct, and I have proposed that the transaction is false and not validated, not valid, right? So this is how the security and security was achieved in the consensus mechanism, because you have to put uh, here your token here to get affected the transaction here, and you have to achieve the consensus over the network, right? So suppose if a majority of the valid approves the block, it gets added to the blockchain, and whoever is the validator who proposed the validation, right, the proposing and attesting validator receives a reward. So in similar to as proof of work, they are getting the rewards. Here also in proof of stake, the validator or the validator node get the rewards, and some, if they are not if they are doing something wrong, so they have to do have to pay a penalty. So validator who act maliciously or go offline can be penalized by the losing part of their stake tokens, right? So this is how the integrity and the security was also achieved, right? So Bitcoin basically, and how security is taken care here is, let's take a scenario, right, compared to Bitcoin. So Bitcoin network is basically Bitcoin network is vulnerable to a 51% attack, right? 51% attack is when a miner or mining pool controls 51% of the network's computational power and creates fraudulent blocks of transaction for himself while invalidating the transactions of others in the network, right? But in proof of stake, what we have done here is, you have to stake your coins, which has to be equivalent to 51%, right? So with proof of stake, the attackers would need to obtain 51% of the cryptocurrency of the entire blockchain to carry out the 51% attack, right? Which is near to impossible, right? Although it would be difficult, but and expensive too. And as soon as the demands and supply will increase, the value of the cryptocurrencies will also increase, and it is very expensive to do something fraudulent over the network while doing the 51% attack, right? uh, and accumulates 51% of the total coin's value. A miner with 51% attack stake is in the coin would not attack a network. He holds the majority share, right? If the value of the cryptocurrencies fall, then the value of holding would also fail. So it never propose the value of the related to the token. If the value is also gets down or the decreases ultimately in the market, then the validation will also fails, right? So in POS system, blocks are forged or minted. As I have told you earlier, blocks are not mined. It is known as a forged or minted. The individual validating the transaction creating a new blocks are called forgers, right? Forgers are the who in is it is similar to a miner. Forger in proof of stake in Ethereum side, on Ethereum side, and the miner on the blockchain of the Bitcoin side. In most proof of stake networks, the digital currencies unit are built at the currency's launch, and their number is fixed. Therefore, the forger receive transaction fee or the rewards instead of cryptocurrencies, right? So, in general, I have told you about the how they get the reward and all, but in actual in proof of stake or the Ethereum side, uh, the transaction reward is related to something, the cryptocurrency or similar to cryptocurrency, and in later on in the process they basically exchange with the other one. A forger must first put their coins at stake to validate the transaction and then create, right? If a forger validate the fake transaction, they lose their coins and their rights to participate in the future, as I have told. So this is how proof of stake works. If anyone having any kind of doubt, please feel free to ask, because it is a very important concept, and you will like get difficulties to understand later on. I'm just taking the question, the doubts of this proof of stake concept. Please ask your question. Shall I move forward, please? Please let me know. Shall I move forward, or you are any one of you are asking any question? Let's move forward then. So now the advantages of proof of stake, that is POS. So energy efficiency, as we are not consuming the computational power, GPUs, electricity, right? We don't need to find the nonce value, the cryptographical mathematical value to basically validate any transaction. So that's how we are saving energy. And it is a randomization, and there is a randomization in process and that prevents basically centralization, right? So no one will try to track the network, as it would vastly decrease the value of the attacker's coin. Now there are various different types of variant of proof of stake. There are various type of proof of stake. So delegated proof of stake is basically inspired by the proof of stake one of the concept, liquid proof of stake, bonded proof of stake, hybrid proof of stake. So these are other consensus mechanism which is derived from proof of stake itself. Now, how what are the areas where we can implement the blockchain? So these are the main core areas where we can implement the blockchain, right? So one of the main example is retail, automobiles, government agencies, services, healthcare, insurance, energy, real estate, finance, e-commerce, entertainment, sports, for supply chain, right? So these are the major concepts where we can implement the blockchain solutions. So these are the other components where we can also implement blockchain, like in robotics. So robot sharing, compliances and auditing, supply chain transparency, autonomous payments, right? So autonomous payments can be handled by the smart contracts on Ethereum or any other blockchain, event-based blockchain, remote and operation monitoring. So using the data authenticity and the transparency, we can also we basically monitor the operations and the decentralized autonomous robots which basically not in control by any one single entity, right? So these are the major components where we can implement the robotics, blockchain in robotics also. uh, Now let's go for this. We have now I'm giving you some questions, right, to answer. I'm giving some question for a quiz. So how we have to decide whether to choose POW or POS? So Sushmita, it basically decided by you. It decided by the user who wanted to use which network. So every network uses a single different single kind of or different kind of consensus mechanism. So as I told, uh, proof of work is basically used by Bitcoin, and proof of stake is used by this Ethereum, and some other network has some other things, right? So you have to choose which network you wanted to prefer. So if you wanted to prefer this Ethereum, Polygon, or Binance, or Solana, or Bitcoin, anyone. So based on that particular chain, you have to incorporate those consensus mechanism in your application or while developing any kind of software or application, right? Hope I have answered your question. So the network, Amit is asking, the network can be difficult to upgrade. Yes, Amit, the network is very difficult to upgrade. So if anything wants to be upgraded, it has to be maintained by the blockchain members itself. So basically, they proposed change, and once they receive the majority of the yes, they will upgrade the things, but it is very difficult and complex task to technically upgrade the things. So as Ethereum upgraded from pure proof of work to proof of stake, right? So it was a very long taking process. And when Ethereum upgraded to proof of stake, Ethereum names it as a Ethereum 2.0, basically a second version of Ethereum, which is based on proof of stake. Is it possible to create our own blockchain for research purposes? Yes, it is possible. You can use Hyperledger, Corda, like these kinds of framework, and you can implement also your blockchain or by like using Ethereum's and Ethereum Polygon, any kind of thing, any kind of blockchain. I'm giving you some questions, right? Then you can answer. I'm confusing DApp and blockchain. So, Sushmita, DApp is an application which is built on blockchain, which communicates which communicates with blockchain network. So, take it as an example as um, you have built a website which is communicating or which is built on internet, right? So TCP/IP connections basically. So you are basically providing services through your website to the other users over the internet. So internet is kind of a blockchain, and DApp is a kind of a website application. Hope I have given you your answer. Any other one having doubt, please ask. Is my screen visible?
Yes, it is visible.
So yeah, here is the question. What is the primary difference between a full node and a validator node? Right. So as I have told you, or we have another question, the 51% attack and the what are the stable coins importance in a DeFi ecosystem. So I'm just putting you the question here. The first question is for why, what is 51% attack in blockchain? So please share your answer in chat box, in comment, sorry, in messages. So what is a 51% attack in blockchain? Attack on 51% of wallet, attack where more than half of the network storage is lost, consensus failure due to validator downtime when one entity controls majority hash power or stake. What does it mean? D C B B C D B, बहुत डिफरेंट आंसर्स मिल रहे हैं. C, C, B. So mostly answers C and B. So the correct answer is when one entity controls majority hash power or the stake. So answer is D. The next question is, why are stable coins important in DeFi ecosystem? They increase volatility in trading. They are issued only by miners. They act as a stable medium of exchange and a store of value. They replace blockchain nodes. What is the answer? I'm repeating question. Why are stable coins important In DeFi ecosystem, they increase their volatility. In trading, they are issued only by miners. They act as a stable medium of exchange and store of value. They replace blockchain nodes. What's the answer? So many of you have answered the correct. Yes, answer is C. They act as a stable medium of exchange and a store of value. Let's go to our next slide. So in blockchain ecosystem, we have different type of nodes, right? What is the node? It is basically a kind of the role assigned to a participant who wants to take uh, who wants to do transactions, who wants to do mining, validation, voting, and their core in and wanted to participate into their core infrastructure, right? So we have different type of nodes. So we have full node, archival nodes, validator node, RPC nodes, mining nodes, prune nodes, full nodes, authority nodes, so and light nodes, like and so on. But in today's section in the scope of course, we will cover only the selected and the important nodes. So our first is full node. So a full node stores the entire blockchain history independently and independently validates every transaction and block according to the protocol rules, right? So in order to completely validate transaction and block against the network's consensus rules, a full node keeps the complete blockchain. So from the very first block, that is genesis block to the current state block, right? Full node has all the data of blockchain and performs the validation independently, right? So this is the very important thing to like note it down. So basically downloads and store all the blocks from Genesis, verify each transactions and blocks like signature, input, output values, double spendings checks, and the roles assigned, the authority level, and so on, right? So it stores all the data and current states. The transaction data that has been spent by the users, the EUTXOs, unspent transactions, and saved balance, all kind of data. Whatever amount I'm having, whatever amount of data is a user has spent, a user having on a particular public address associated with how many transactions he has done in previous, right? So all the relevant data are all the interlinked data that is related to any user. uh, these are the data stored that is being uh, done by the full node. Use case. So basically what is the use case of this? So blockchain explorer is kind of a use case where a full node basically use as to provide the transparent and open data to everyone, right? So blockchain is one of that kind of a concept where full node can be implemented. uh, and it wallet software connecting to reliable nodes, like developer verifying the transactions. So whenever you wanted to check that I have whatever transaction I have done is has been initiated or not, so you can basically check that thing from the blockchain explorer, which is basically a use case of full node. So you are connecting your application with the full node APIs, right? And then you are reflecting the all the data over there for the auditing purposes and all. So Bitcoin full node verifies all the BTC of Ethereum. Bitcoin or Ethereum full node verifies all the Ethereum transactions, right? So that's how full node work. Next node comes is a mining node. So basically, a mining node is a full node. It's a kind of a full node basically, which is a kind of a concept in proof of work, consensus mechanism wala part, where Bitcoin is basically important in Bitcoin blockchain where the minings happen. So participant in proof of work by competing to create new block through computational puzzles, right? So use it basically, mining nodes use hardwares, and GPUs, CPUs, right, to perform complex hashing calculation, finds valid hash, and then propose to a network to add a block into a blockchain, broadcast messages to network once they wins the validation process and the competition within the particular ecosystem, right? So all these data is being stored by these kinds of node. So block reward they get, and mining nodes basically, whenever they propose a data, propose any transaction to be validated, to be added into a network, they get a reward in after these successful operations, and the transaction fee whatever has been done by the users or the network, right? So it needs full nodes software, basically because it is a kind of a full node, so it needs a software to be incorporate to be installed on the machine by the user or whoever is the participant wanted to be, right? It needs mining software and highly computational configuration of machines to be into existence, right? So this efforts requires figuring out the integrate mathematical operations, which is hash output and all. So that's how it works, mining node. uh, Now next here is the validator nodes, which is a concept of basically Ethereum. A validator node, also known as a staking nodes in certain networks, participate more actively in blockchain building process than the standard full nodes, which are mainly responsible for transaction validating and relying, right? So in node proof of stake, all similar consensus mechanism that validate blocks by staking tokens instead of mining. So it basically how it what are the main functions it does. So proposes and verifies the new blocks and stakes cryptocurrencies or the tokens to participate in the consensus mechanism. They get rewards validating by validating the block correctly. They face the penalty when they are doing something unauthorized activity or some malicious activity, right? Behalf of on the behalf of that activity, they will be penalized by the network, right? uh, and they need a minimum amount of 32 ETH in the validation process. The standard has been set by Ethereum to 32 Ethereum you have to take participation in staking mechanism, right? Always online, you have to be always available online. Your status has not to be disconnected or not available. If you lose your date if you lose your connection and the online status, you will lose your staking rewards, staking tokens, whatever you have done, you have staked in the process. So in Ethereum in Ethereum you have the staking validation nodes. In Solana, Avalanche, Cosmos, and other blockchains are there, who has these kinds of nodes available in the network. Next here is the RPC node. So basically, it remote procedure call. Its full acronym is remote procedure call, or RPC nodes are the essential access point. They execute the request and carry out the certain tasks. So basically, in simple words, an RPC node provides an interface, that is API, for application, wallet, and scripts or dApps. So as asked by a question asked by user, how what is the difference between blockchain and network, the confusion, right? So here RPC nodes providing the API, basically it is providing you the gateway to communicate with the network, right? So dApps basically application, the software you have built for your mobile, your desktop, or anything, right? So you are communicating with blockchain directly via RPC nodes. So RPC nodes are the kind of a mediator where we are putting your request, and then RPC nodes are sending those requests to blockchain network servers and nodes, and then you are getting the request back, right? So basically it provides the HTTP calls, WebSocket, and API calls. It read and writes the data on the blockchain, get transaction details, submit new transactions, read contract states. So whatever the state transaction state have executed, successful, failure, right, and the error. These kind of states you get from the RPC nodes if you are executing any kind of blockchain network, any kind of transaction over the network. So in front-end wallets, so as I have told you, the wallets, right, Web3 dApps, developer tools are the use cases where we are using the RPC nodes to communicate with the blockchain networks. So every blockchain has their own RPC nodes to interact it with. Right. So Infura, the examples are Infura, Alchemy, QuickNode provides managed RPC infrastructure for Ethereum and others. So these are the very important nodes to communicate with the blockchain. Now let's come to the final one, the archival or the archive nodes. So an archive node is a more advanced version of complete node that retains data for a longer period of time. And an archive node not only saves the whole blockchain but also painstakingly preserves all previous network states, so including all the transaction state between blocks. And right, an archive node's full node, kind of a full node, basically additional storage of all the intermediary states, so state try, account balances, smart contract storages at every block, right? These are the information as is being stored by archival nodes or archive nodes. So it stores entire historical chain, full data, full state of every block, right? Historical balances lookup. So supports historical balance, um, past smart contract states, event logs, whatever event has been generated by anyone in the network and of by any network member node, right? So state transition from Genesis block to current state. So it is very bulky, right? Required terabytes of state storage to basically store all the data. So it basically store all the data and the metadata of the blockchains, right? So Explorer is also where we can use Explorer is a use case where we use the archival nodes or archive nodes. Why we need these kinds of archival nodes or archives nodes? So when any company or any organization or any network wants to do some auditing or compliances, following any kind of compliances, then these kinds of things comes into a picture where it helps out the organization and the individual organization or the consortiums to manage these auditing processes and purposes, right? So that's how it is important. Now the this is the difference of the all type of nodes we have covered so far. So as we have covered, so I'll share this with you all so that you can also get to know about this thing, the differences. Now takes a this a real world application from a real world example, right? So MetaMask, where is the platform where we are using the RPC nodes and basically queries the balances, broadcast transactions, do sending, receiving of tokens and assets through your wallet or your application. Bitcoin mining rig is another example, platform where we are using the node type of this mining node. So it basically mines block on BTC, right? And Etherscan is a platform developed by the Ethereum Foundation, where archival nodes are used, where you can see all the full transaction details of any network, balances, history, user details, balances, any kind of details you wish for. Now, the second last is Ethereum validator. So it is a validator node secures network by staking ETH, right? and verifies verifies the validation processes. But the last one is Bitcoin full node. Full node basically verifies and relays transaction independently. So these are the real world examples of applications of all the type of nodes and in the blockchain ecosystem. So let's come to this table where we have to cover this thing, right? Full node. So basically, as I have told you, so stores all the data of the blockchain. And participation in consensus, no, it never participates unless it is not a miner or a validator, right? So it is used by DApp. Yes, it is used by DApp. And what are the primary roles? So validating and verification of broadcasting of transactions. So any minor so in, so full node is a umbrella term for becoming a full node can be a miner or can be a validator. So it has kind of a two role. So mining node is the another one, and the validating node is another one. All right, so we will cover this in later. So validation and verification kind of processes it carries out. In mining node, a node that performs and complete computation to find new blocks, block creation and earning mining rewards. So data stores blockchain data. Yes, it stores. Participate in consensus. Yes, it participates. And proof of work consensus, basically because the mining process is there, as I have told you. So full node is a umbrella term where mining is a part of a proof of work consensus mechanism, and validator node is a part of a proof of stake consensus mechanism. So it is used by dApps. So no, it never used by dApps. Validator nodes. So yes, validator nodes that takes the token and gets selected to validate a block in proof of stake blockchains, proposes the attest blocks and secure the network basically. So the very first step to secure any blockchain, any transaction to be hampered or to be tampered by any malicious node, any malicious participant. The validator node is the first soldier to prevent this thing to be happen. So it stores the blockchain data. Yes, usually full node 2. It basically use the full node data and uses the consensus mechanism of POS. Is it never communicate with the dApps because it's a validator, so it operates in the backside on the backside of the network to manage the network operations. RPC nodes, as I have told you, so it is a gateway between application. So it is a kind of a mediator between the application or the users and the blockchain core infrastructure. So if you wanted to communicate with the network, you have to use the RPC node. And using their RPC nodes, how you can use, you can use their APIs provided by the relevant blockchain networks, and you can call the any kind of the methods they have provided for their functionalities, right? So proof of they don't use any kind of consensus mechanism, but yeah, it is used by the dApps here, right? Now the last one is the archival node. So it is a special full node that stores the entire data for the deep query and indexing and kind of auditing and compliances formation. So it is used by the data dApp also. So that is the entire end-to-end process, right? Uh, Let me know if you have any kinds of any doubt or any related things. So I'll put some questions for your I'm giving you some questions for these networks kind of things. Please feel free to ask your question. I'm giving you some questions related to these nodes. Hope you have gone through all the things. How sidechains mechanism use these nodes? I mean, inside a chain, which node is validator side chain or main chain? So, Barbie, side chains basically executed when we do forking. When we apply the forking mechanism. So forks are the concept of the blockchain. When we are separating from the main chain and creating our own separate infrastructure of a blockchain, which is ultimately communicating to the main chains. Content, is it okay? So let's start with our quiz for the rest of the part. I'm sharing my screen, and let's please share your answer in the chat box. Hope my screen is visible to all of you. So our question is, what makes blockchain immutable? So we have the options here: ability to change old transactions, uh, encryption of messages, hash linking of blocks and consensus verification, government approval of each block. What is the answer of this? I'm repeating the question. What makes blockchain immutable? So I have like described this thing, the immutability, which is a main component of the blockchain in very first lecture, right? Ability to change old transaction. So immutability means you cannot change the data, right? So how blockchain is applying immutability, right? So along in the given options, what are the correct option? Which one is the correct option? So ability to change old transaction, encryption of messages, hash linking of blocks and consensus verification, government approval of each block, right? So which one is the correct? I'm getting I just got 1 2 3 4 5 answers I got. So answer is C. Yes, all of you are, your answer is C. So Juhi, B is not a correct answer. Second question is, which node is more suitable for decentralized application to fetch real-time data from the blockchain? I'm repeating, which node is most suitable for decentralized application to fetch real-time data from the blockchain? I just covered this topic, just a few minutes back. So our options are mining node, RPC node, validator node, and archival node. Which one is correct? Please paste your answer, please, in chat box. So mining node, what is mining node? Mining node basically is a node that takes care of the mining or the validation of the transactions, right? When they propose the nonce value to the network and then get the validation from the other peers. RPC node basically, it is a node basically providing you the infrastructure or the APIs to connect your applications and connect it with your dApps, right? So correct answer here is RPC node. Validate what validator nodes do? Uh, validation process, the process of validation, right, in the Ethereum network. So validator nodes are part of a Ethereum blockchain, and mining nodes are part of a, you can say, blockchain, Bitcoin network. Archival nodes where basically we are storing all the data of the blockchain from very beginning to end, right, from the current to the current states. So yeah, so as archival node is used for investigation purposes, but it is not used for the dApps. So dApps related to only RPC nodes. Now let's go to next question. Which type of blockchain node is required? Which type of blockchain node is required to maintain decentralization and ensure the network security, even if it doesn't mine blocks? So our options are full node, mining node, RPC node, and validator node. Which type of blockchain node is required to maintain decentralization and ensures the block network security, even if it doesn't mine blocks? This could be a little bit tricky question, but please answer your answer in the chat box. Yes, it is A. Answer is A, full node. Now let's come to next question. What is the role of an RPC node in a dApp ecosystem? What is this role? So I just tell you the answer before the question, this question and the previous question, right? So you have to tell me the correct answer. Our options are process block validation, stake tokens in for rewards, provide data access and submission interface for apps, or stores fiat currencies. So which one is the correct one? Okay, Shivaswamy, Harshit, Bhargavi, Geeta, Juhi, Shilpa. Only these 3, 4, 5, 6 person are active only in this the entire session. Yes, so this is correct answer. C is correct. So our today's last question. What is the primary difference between a full node and a validator node? What is primary difference between full node and validator node? Validator node stores more data than full node. Validator node only reads transaction. Full node proposes new block. Validator node participates in block creation and consensus. Which one is correct? Validator node participates in block creation and consensus. Yes, correct. Answer is D. So the main primary role of this validator node is to participate in the block creation and the consensus, basically, because this node has to provide the validation, and after that validation process, only that transaction gets added to that particular block, and then ultimately into a blockchain, right? So we have covered so far till now. So that is from my end. If you are having any questions, any doubts related to today's session, the topics we have covered so far, please feel free to ask your question, any doubts related to that. I'm open for your questions. We are having 2 minutes here. So please paste your doubts and questions. Sure, Pani ji, I'll provide the resources for day 2 and day 3 also. Okay, thanks everyone. If you are not having any questions, let's close this session, today's session. Sushmita man, I'm done with my today's session.
Yeah, thank you. So we'll meet
Thank you.
again tomorrow.
Thank you everyone. Have a nice evening.
Yeah, thank you, sir. So, yeah, dear faculty members, as I have shared attendance link on the chat, so kindly mark your attendance. Okay, so yeah, thank you all. Thank you for joining. We'll meet again by 3 p.m. Thank you all. Have a great day.